third year, welcome to our first lesson on our new topic, Nature's Chemistry. Today we are going to be focusing on Lesson 1, Fossil Fuels, and Lesson 2, Distillation. They're both very short lessons and hopefully you will not find them too complicated. So our learning intention for our fossil fuels lesson are for you to be able to define fossil fuels and describe how they are formed. By the end of our short lesson, you should be able to explain how coal, oil and natural gas were formed and define fuels and fossil fuels. So first of all then, what are fossils? So fossils are the remains, impressions or any evidence of life from a past geological age. So we are thinking dinosaur remains, the imprint of animals long past. That's what a fossil is. So how do we go from fossils to fossil fuels? Well, fuels are substances that can be burned in order to release energy. You might think coal or wood for a fire, petrol for your car, or the gas with which you might cook at home. So fossil fuels then are fuels that were made from the remains of dead animals and plants from millions and millions of years ago. We know them as coal, oil, and natural gas. So what we are going to do now is we are going to read through some information on the next 2 slides, and then we are going to use that information to complete the notes in your jotter. We're going to read some information about fossil fuels. Now, I will make these slides available to you so that you can see the information cards and read them yourself. You can pause the video and do that now, or you can hang on and I will read through the cards for you. So coal formation. Coal was formed from the remains of plants which grew in huge forests about 300 million years ago. As the plants died, they fell down and began to rot. The rotting plants formed a thick layer on the wet and swampy floor of the forest. The action of bacteria changed the decaying plants to peat. Peat is used as a fuel in some countries. It's the first stage in the formation of coal. Gradually, the land sank and water covered it. Layers of mud and gravel were laid over the decaying plants. As more and more rocks were laid down by the seas above, the pressure on the peat layers increased. The temperature also increased. Eventually, over millions of years, the decaying plants were changed into coal. Oil formation. Millions of years ago, tiny sea creatures and plants lived in areas such as the North Sea. When these organisms died, their bodies fell to the seabed. There, they were covered in sand and silt, which formed a sediment. Layers of sediment built up over millions of years. The high pressure from the many layers changed the sand and mud to sandstone and mudstone. The high pressure and temperature changed the organisms to oil and gas. So your job now is to complete this summary here in your jotter. So your title will be Fossil Fuels because that's today's lesson, and you will write a little smaller title, Coal Formation, and take these 3 bullet points down. So swamp plants die and get buried under dirt and water. Over millions of years, layers of dead plants are buried deeper and deeper. The heat and pressure, along with the absence of oxygen, mean that coal is formed over millions of years. You then have to take the subheading Oil and Gas Formation and take the following 3 bullet points down. Layers of dead sea creatures settle on the seabed. Layers of sedimentary rock build up on top. The heat and Pressure from these rocks, along with the absence of oxygen, mean that oil and gas are formed over millions of years. So let's summarise then. Let's bring everything we've just talked about together. So fuels are substances which release energy when they are burned. Fossil fuels are made from the remains of dead plants and animals and were formed over the course of millions of years. Coal was formed from the remains of swamp plants that were buried and put under intense heat and pressure by layers of rock and sediment building on top. Oil and gas were formed in a similar way, but under the seabed from the remains of plants and animals which were buried under layers of sediment and put under intense heat and pressure. Coal can be extracted by mining. A lot of us may have family history, particularly in the Coatbridge area where we have Summerlee, can be extracted by mining, so we mine coal from the ground. Oil and gas are extracted by drilling into the seabed, and you might be familiar with oil rigs. We have some out in the North Sea. So that brings us to the end of our very short lesson on fossil fuels. We are going to move on in a moment to distillation, but let's take a minute to review what our intentions were for this half of the lesson. So we were aiming to define fossil fuels and describe how they were formed. At this point, you will hopefully be able to explain how coal, oil and natural gas were formed, and be able to define the term fuels and fossil fuels. Now, our second lesson is on a process called distillation. Now, in order to understand distillation, we've first got to understand the states of matter: solids, liquids and gases. We will take that information and we will then describe the process of distillation and what we might use it for. At the end of this half of the lesson, you should be able to determine the state of a substance at room temperature. A lot of us can already do this using melting and boiling points, and describe the process of distillation and give me examples of what we might use it for. So let's go back and think about melting and boiling points. Now remember, this little green man holding the pencil means you have to be writing this down. So different substances have different melting points, and the melting and boiling points of some substances can be found in the data booklet. If the boiling point is below room temperature, and we tend to say 25 degrees as room temperature, then the substance will be a gas. If the melting point is above 25 degrees, then the substance will be a solid. If the melting point is below 25 degrees, but the boiling point is above 25 degrees, the substance will be a liquid. So what I want you to do just now is stop here and complete the melting and boiling point refresher quiz. After you've done that, come back and we will continue on with distillation. So just as a quick reminder, when a solid becomes a liquid, it melts. And when a liquid becomes a gas, it evaporates. Now, to go from solid to liquid to gas, we have to add energy. And we add the energy by heating the substance up. Now, if we were to go back the way and go from a gas to a liquid, the gas is condensed. And from liquid to solid is called freezing. And in this case, we remove energy. We take away heat. We cool everything down. And we go from gas to liquid to solid. So, let's go back to our fossil fuels. The one that we are going to focus on for right now and going forward is oil. Now, oil is extracted from the seabed by these big oil rigs. It is then taken to processing plants where it can be separated into different parts. Because you see, oil is actually a combination. Because you see, oil is actually a big mixture of compounds. It's not just one thing, it is many things. And we have to separate this mixture into its different compounds in order to be able to use them for a range of different things. Now, the way that we separate oil out is we use a process called distillation, and I'm going to run through that with you right now. So distillation is the separation of a mixture based on boiling points of the different compounds within. So what we have here, for example, is a solution of ethanol and water. Now we've placed the solution in a heating mantle, that's what this is here, and we are going to heat it up to 78 degrees centigrade. Now at 78, ethanol will boil and change to gas. It will evaporate. The gas will travel up the flask and down through this pipe here. Now this pipe is surrounded by a sleeve which brings cold water in at the bottom and pumps it out at the top. Now it makes this part of the pipe extremely cold, or much colder than the 78 degrees from our beaker. So inside this pipe, inside this tube, your ethanol gas will change to liquid. It will condense. The liquid will then pour out of the tube and into our beaker here, and we have pure ethanol, what we would call our distillate. So I'll run through that again. Distillation is how we separate mixtures in the form of liquids into their different compounds. So what we have here is a solution of ethanol and water. We use a heating mantle to heat the solution to 78 degrees C. At this point, ethanol will boil and become a gas. It evaporates. The gas then passes through this side arm into this tubing. Now the tube is surrounded by cold water, which is pumped in at the bottom and out at the top. The difference in temperature allows the ethanol gas to condense into a liquid, and the liquid then pours out of the tube and into the collection beaker at the bottom. So our summary, which I need you guys to make a copy of, is oil is a mixture of compounds. Liquid mixtures can be separated using a process called distillation. Distillation separates mixtures based on their boiling points. Now, because each compound will boil at a different temperature, they can be collected separately. In this example here, we have a solution of ethanol and water. Now, ethanol is boiling and becoming a gas at 78 degrees C. At this point, the water is warm, but it is not changing state because it doesn't boil to 100 degrees. So we can separate ethanol and water because they have different boiling points. Now, as well as using distillation to separate oil into distinct compounds, we also use distillation in the production of alcohol. Distilleries are used to produce whiskey, vodka, and a range of different alcohols. So let's summarise then our learning intentions. Our learning intentions were to revise the states of matter, we've gone over that already, and describe the process of distillation and its uses. We've talked about how distillation works. It separates liquid mixtures based on the boiling points, and we can use it to separate oil, which is one of our fossil fuels, and also to produce alcohol. Hopefully, you should be able to determine the state of a substance at room temperature, 25 degrees, based on its melting and boiling points, and describe the process of distillation, giving examples of its uses. So that brings us to the end of our very short double lesson today. I appreciate that it was incredibly quick, so if anyone has any questions, please get in touch via email and let me know if there's anything I can do to help. Take care guys, and I will see you all in the next one.